Good afternoon, students. Today we are going to discuss about the liquid junction potential and its derivation and its eliminations and derivation of liquid junction potential. So liquid junction potential, right? Liquid junction potential. Liquid junction potential means, so when there exists a concentration cells with transference, that time there exists a liquid junction potential, it is LJP. So liquid junction potential, so the derivation of LJP we are going to do. So next, in this actually what happens, so first generally we know that already we discussed yesterday, LJP means, so E with minus, E without, right? E with minus, so EMF of with cell minus EMF without cell, right? So that already we know that these values directly in previous class. So directly I am going to write. So first I am going to write the cell. Cell is what? Platinum H2, platinum H2 in H plus. So that is with salt bridge. So that is what? H plus in H2. This is A1. This is A2. I am going to write. This is at platinum. So from Nernst equation. From Nernst equation I can written as E with is equal to what? So from Nernst equation, because it is a salt bridge, it is E without. E without formula already we discussed. That is what? RT by F ln of A2 by A1. RT by F ln of A2 by A1. So same, if I wanted to write another cell, that is what? Same H2 in H plus. So that is with, this is without, because we are using the salt bridge where it is used with the semicolon symbol. That means we are using the with transference. So that is what? H plus of H2 at platinum. So that we can write as, this is A1, this is A2. If I am going to write E with transference formula already yesterday we discussed in the class. E with is equal to what? 2t minus, E with is equal to 2t minus RT by F ln of A2 by A1. So both we get directly. E without from Nernst equation we got, from E with also we got the two equations. Now what I am going to do is, so E LJP means E with minus E without. So E LJP means what I am going to do, so E with means E LJP means E LJP I am going to do. E LJP is already we know that E with minus E without. E with minus E without, right? So from this E with minus E without, so already we know the values. E LJP is equal to, E with values is 2t minus RT by F ln of A2 by A1, So if I want to write E without is this value. This value is what? Minus RT by F ln of A2 by A1, So from this is common term. This is I am going to take common term. E LJP means, so that is what? 2t minus 1 into RT by F into ln of A2 by A1. RT by F into ln of A2 by A1. This is 2t minus 1. So already yesterday we discussed what is that? T minus plus T plus is equal to what? 1. So if I wanted to write T minus 1, if I wanted to write, that is what? Minus T plus we will get. So from this here 2T minus are there. So that 2T minus I am going to write T minus plus T minus minus 1. I can written as, this is T plus 1 plus 1 is 2, right? Like T minus plus T minus is 2T minus, that is minus 1 is as it is. Simply if I want to write in place of T minus 1, I can written as minus T plus. So that I will get E LJP is equal to, E LJP is what? Directly you can write T minus, this value is minus T plus into RT by F ln of A2 by A1. This is final derivation equation for the E LJP, E liquid junction potential. This is the final equation. E LJP is equal to T minus T plus into RT by F into ln of A2 by A1. So this is about the E liquid junction potential. So now we are going to do some conclusions for that. So generally LJP is mainly depends upon transport number of cation. LJP is mainly depends upon the transport number of cation and transport number of anion. So just if transport number of cation is equal to transport number of anion, what we will get? So this value is equal to this value. If it is value is 100, this value is also 100. 100 minus 100, that is 0. So if transport number of cation is equal to transport number of anion, that time LJP is minimum, that is 0. LJP is 0. So when first you need to write some conclusions here. What is that? First case, if transport number of cation is equal to transport number of anion, LJP is minimum. LJP is 0 or LJP is 0 you can write. Right. If transport number of anion is greater than the transport number of cation, LJP is greater than 0. LJP is greater than 0. So that means if value is 100, for example, this value is 50, what we will get? 100 minus 50. So that means transport number of anion is greater than the transport number of the cation, we will get LJP is greater than 0. So in case if we will get T plus is greater than T minus, that means if it is 100, T plus is 100, so T minus is what? 50 if you will take. So what we will get? 50 minus 100 is minus 50. So like LJP is less than 0 you will get. So LJP is less than 0 you will get. So salts, like you can write conclusions, all these conclusions you can write in the examination. So when this LJP is eliminated means, so whenever in the cases salts like KCl, ammonium nitrate, NH4NO3 and KNO3, agar-agar gel. So in these salts, equal there is a transport number of cation is equal to transport number of the anion. So that cases, so generally LJP is 0, LJP is minimum, LJP is negligible. So salts like KCl, KNO3, NH4NO3 etc. So these contain the equal number of the transport number of cation and transport number of the anion. In such cases, the LJP is minimum. So that's why these type of salts are used in the salt bridge. These type of salts are used in the salt bridge. These are used in the salt bridge. This is about the liquid junction potential derivation and its eliminations. In some conclusions we are going to write directly. You should remember the formula for competitive exams, like some CSR exams they will ask if they will give the transport number of the cation and anion. So they will ask to find out the liquid junction potential. For that cases, LJP is equal to T minus T plus into RT by F into ln of A2 by A1. That you should note it. You should by heart that formula. So this may be asked for 4 marks or 6 marks, whatever it is. So please go through it. Thank you.